Our lesson today is going to be Chapter 3, Lesson 2 on estimating decimals. So before we get started, please make sure your textbook is open to page 185. Make sure you have that textbook ready to go, a pencil, and a highlighter. If you need to, pause the recording now and turn it back on when you're ready. All right, starting on page 185 in the real world link, they said that in skateboarding, the record for the greatest distance traveled on a skateboard in 24 hours was set in a recent year by James Peters. He traveled about 7.6 miles per hour. So they'd like us to, plot 7.6 on the number line. I'd like you to go ahead and try to complete this page and then turn on the recording again and we'll go over the answers together. So pause now and turn it on when you have this completed. All right, so we would round off 7.6. It's closer to 8 over here than the 7. 7.6 would be about here on the number line. So we could estimate that he traveled 8 times 24 for about 192 miles. And my estimate is going to be higher because I rounded up to 8 rather than down to 7. Ted McDonald also set a new record, and he traveled about 10.1 miles per hour. How much farther did Ted McDonald travel? Well, we take 10.1 and estimate and round that off to 10 times 24, or 240. So to find the difference, I take 240, subtract 192, and get 48. So we could say that Ted McDonald traveled about 48 miles further. Okay, so today we're going to be talking about estimating products and using some rounding to round off our numbers. If their digit is 4 or less, remember we don't do any changes. The digit stays the same, and if it's 5 or higher, we add 1. So if I had 9.86 and I wanted to round it to the nearest whole number, I'd underline the 9, and I always like to circle that number behind it and then draw an arrow. Is this 8 going to be high enough to push the 9 to change its name? And in this case, following the rules, 8 is 5 or higher right here. So yes, it's actually going to become 10. If the number had been 9.36 instead, and I wanted the nearest whole number, I'd look at that 3, and the 3 is too small. If it's 4 or less, the number is going to stay the same. So I would round this number off to 9 instead. So let's look at some examples in the book. They say estimate 8 7/10 times 2 8/10. So looking at the numbers, we're looking at the 8. This 7 is big enough to push the 8 then to 9. And on this number again also, the 8 is big enough to push the 2 to a 3. So our estimate would be 9 times 3, or 27. So the product is about 27. All right, on this problem, they want us to estimate 42.6 times 37.2. And remember, the goal of our estimating is always to make it so we can do our math mentally. So they said round to the greatest place value to make it easier to compute mentally. So looking at this one then, the greatest place value is the 4. So is this 2 big enough to push the 4? It is not. So we're going to round off to 40. Here on 37.2, the 3 is then the largest place value, and that 7 is big enough to push the 3, so we're going to round to 40 as well. So let's transfer our two numbers in here and find the product. Well, when we have 2 zeros, we know that we're going to end up with 2 zeros at the end, and then 4 times 4 is 16. So our product would be about 1,600. Let's go ahead and estimate these products. Be very careful that you go to the biggest place value. So we're going to focus our efforts on rounding the 9 and the 1, the 4 and the 3, and you're going to go to the 6 and the 2. So remember, those are your largest. So let's go ahead and do A together. So 9.6 then, we're going to be rounding to the nines, so that 6 is big enough to make it a 10. And then if we have 1.8, we'll round to that 1, and this is 8 is big enough to push the 1 to a 2. So we want to take and find the product of 10 times 2, which is equal to 20. All right, go ahead and try problem B and C here on the Got It's. Make sure you're showing your work and your estimates. Then I want to see your circles and your arrows on the page. And go ahead and turn on the recording when you're ready to check your answers. All right, let's see how you did. We should have 4.2 can round then to 4, and 3.1 should round off to 3, so 4 times 3 is 12. Over here, 68.4, we'd round to the 6th, so the tens place, so the 8 is big enough to push the 6 to a 7, so we'll make it 70. And the 1 is not big enough to push the 2, so we're going to make it 20. So 70 times 20 is 1,400 or 1,400. If you're having trouble, make sure you stop the video and come and ask me for help. Alright, let's apply this to story problems. A greyhound can travel 39.3 miles per hour, and at this speed, how far could the greyhound travel in 6.5 hours? So, we're going to go round to our greatest place value, and the 9 is big enough to push that 3, so we'll make it 40. And the 5 is also big enough to push the 6 to a 7, and 40 times 7 is 280. So we could say a greyhound could travel about 280 miles in 6.5 hours. So let's go ahead and try this one. Suppose a US dollar is equal to 5.8 Egyptian pounds. About how many Egyptian pounds would you receive for $48.50? So go ahead, why don't you guys try this one on this page, fill in the blanks, and pause the recording and try it on your own. Remember to round to the greatest place value to make it easier to do the math in your head, and turn on the recording when you're ready. Okay, so I went ahead and rounded 5.8 to 6 and 48.50 to 50. So 50 times 6 would be about 300. So $48.50 is about equal to 300 Egyptian pounds. All right. So let's go ahead and have you try a couple of these story problems. Let's do one together. And remember, we're just estimating. So the Earth is rotating around the Sun about 18.6 miles per second. About how many miles does it travel in 4.8 seconds then? So we'll take the 18.6 and our 4.8, and let's round them off. So this 8 is big enough to push that 1 to a 2, so let's make it 20. And the 8 is big enough to push the 4 to a 5. So let's take 20 times 5, and we'd say about 100, and we would say it would be 100 miles. All right, go ahead and try E and F. Pause the recording, try them on your own, and then turn on the recording to check if your work matches mine. Okay, so I took the 4.8 kilometers and wrote it down and rounded that to 5, and in 3 hours, and the 3 is already a really nice number, and it works. I can do 5 times 3 fast in my head, so I did 5 times 3 equals 15. I didn't have to change this one. Don't forget your label of kilometers. On the next one, the king palm grows 2.1 feet per year. So I rounded the 2.1 to 2. And after 15 years, it's a nice round number. And I can do 2 times 15 in my head easily and get 30 feet. So let's go with one last story problem. Patrice has $20 to buy 5 binders. And binders cost $4.29 each. Does she have enough money? Explain your reasoning. Well, we can tackle this one with some estimating. If we take 5 binders and multiply that, and we take the $4.29 we can either try rounding that down to 4, or we can round it up to 5. So if we go ahead and round it to 4, 5 times 4 is 20, and 5 times 5, which is 25, we can go on either side of this. The estimate then, our answer, has to be between $20 and $25. So therefore, Patrice does not have enough money to buy the binders if we actually do the work. For tonight, let's go ahead and practice makes perfect. Page 189 through 190, I'd like you to do problems 1 through 8 all and number 11. If you want to go for the bonus extra points, go ahead and do problems 1 through 15 all. Good luck, and if you have questions, make sure you come and find me.